So this is, as I said, it's a little tricky to really prove that f of x is an odd function, to prove it formally. By looking at the graph, it's quite obvious that it's odd. Okay, it has a point reflection symmetry at the origin. That's no question at all. But it's a little tricky to handle these terms. Let me just try and explain. So we have to prove that in general it holds that f of minus x equals minus f of x. So that's just the formal version of saying that if I'm at a certain position x, right, let's say on the right, and I jump to the left to the corresponding opposite number, the function value must change its sign. As I demonstrated before, if I'm here having or using that f of 1 equals 1, and I jump to this x position, then f of negative 1 should be negative 1. So this is a point reflection symmetry. And then in the end, after all, it means it's an odd function. So looking here again, what do? I take this whole official definition of our function f of x, this one. Okay, so this is not needed. I could, just a second, I could take this away. We don't need it now. And I have to replace x against negative x everywhere. So I would say f of minus x here is then equal to, and now I replace x against negative x. Okay, let me just do it again, so you can more easily see what happens. Just a second. Okay, but no, that's wrong. This one. Yeah. Is it? No, it's not. I lost my, yeah, that's it. Okay. Look, I would say f of x, f of negative x equals, and then in my three cases here, I would get negative x, now 2 plus x, of course, minus x is plus x, and then minus 2 plus x. And now you may wonder why I have written something else here, because the positive 2 and the negative 2 are exchanged in a way. But it has a very important reason. If this were the correct result, and if it hold it for our intervals, 1, 2, 3, which is, don't forget, this is middle interval, right interval, left interval, this would not be a proof, or it would be actually it would be a contradiction to our demand that f of negative x should be negative f of x, because 2 plus x is not the negative of 2 minus x, not at all. Neither is negative 2 plus x the opposite of negative 2 minus x. It's not. But the point is, I must also replace x against negative x here, and here, and here. And that's why, in the end, this interval definition, x greater than 1, transforms to be negative x greater than 1. And if negative x is greater than 1, it means that x is lower than 1. You see here, negative x greater than 1. This is an inequality, an equation, whatever, which may be multiplied by negative 1 on both sides. But then, you know, the rules about inequalities, you have to change the comparison sign also. So if negative x is greater than 1, I get x is lower than negative 1. And that's why the term which I constructed here, this one, must be placed into interval number 3, which we defined to be the left side interval. And that's why, well, here I wrote 1, 3, 2, okay? I just leave it away. It should not confuse you. It's important that this holds for x lower than negative 1, so it belongs to the left side of our graph. And then, after all, comparing red with red, otherwise we would be comparing apples with peaches or something, you see. We must compare apples with apples. And that's why now we have to see or to prove that this term is the negative of this one. And indeed, if I take the negative, the opposite value of 2 plus x, I get minus 2 minus x, and that's it. Also, the same thing. I hope you can follow my considerations. Replacing x against negative x here, I get 2 plus x, of course, but this does no longer belong to the right-hand side. Now it belongs to negative x greater than 1, which is to say here, no, I'm sorry. Now I lost my, I think now I lost my track. Yeah, I was explaining this before probably. Anyway, replacing x against negative x here, I get negative 2 plus x, but now it belongs to negative x lower than negative 1. This is this interval here. And then modifying this on equation, just transforming it, this means that x must be greater than 1. So this transformed expression, negative 2 plus x, belongs to the right-hand interval. The other one belongs to the left-hand side. I don't know if I explained the same thing twice or whatever, but it's important to see by this important step, these two intervals get exchanged against each other. And after all, let me just remove all these blue notes here. Just a second, yeah. After all, we can check whether this equation is fulfilled so that in the middle area, what we get as a function value, which is x here, gets replaced against negative x, which is the negative value of x. And this one gets replaced against negative 2 minus x. Okay, if I take this whole quantity and change its sign, I get negative 2 plus x. And here, if I change the sign, I get positive 2 plus x. So that's everything fine. That's the proof that in general, it holds that f of negative x equals negative f of x. I know that no matter how I explain it, it's a little hard to understand because of this tricky exchange of two intervals, which is necessary for the proof to be valid in the end. But after all, we all know it's a fact that this is an odd function, but it's a little inconvenient to formally prove it. Okay.